Well, it's okay. Now we are going to start with the first lecture about the advanced communication system. Now, first of all, let us talk about the course organization. I'm going to go to the whiteboard. Okay. Mobile. Okay. Well, now the course will be Advanced Communication Systems. Of course will be divided between two parts. First one will be wireless communication, and the second part will be the fiber optic communication. As you know, wireless communication, I'm going to talk about the wireless communication topics. Fiber optic communication will be given by Dr. Saleh. Now, wireless communication consists of basically the following parts. First of all, we are going to talk about the cellular communication system, and then we are going to talk about CDMA system. Of course, in the cellular communication system, we have many topics. The most important topics are what are the properties of the cellular communication system is what frequency reuse. You have to understand what do you mean by the frequency reuse. Frequency reuse, which is the very important point in the cellular communication system. System capacity. And we have techniques to increase the system capacity, which are cell splitting and cell sectoring. Cell splitting and cell sectoring. Okay. And again, we are going to study the interference which affects the performance of the system, of the cellular communication system. And so we have basically two kinds of interference, which are co-channel interference, and adjacent channel interference, and adjacent okay. So this is regarding to what? Regarding to the cellular communication system. Of course, to measure the capacity of the cellular communication system, we have to use Erlang B and Erlang C formulas. Erlang B formula will be used for the blocked calls clear system, and Erlang C system will be used for the delayed calls. So we can estimate the system capacity using these two techniques. Well, this is about what? About the cellular communication system. In CDMA system, basically we have two kinds of the CDMA. We have the direct sequence separate spectrum system and a frequency hopping separate spectrum system. Okay, so either going to use the direct sequence separate spectrum or frequency hopping separate spectrum. Then, if you are going to make a mix between direct sequence separate spectrum and the frequency hopping separate spectrum, we have another kind. This kind is called hybrid system. Okay, hybrid separate spectrum, hybrid spread spectrum. This is about what? About the layout of the course. Of course, again, with the cellular communication CDMA, again, we are going to make a short review about the satellite communication. Okay, satellite communication. And in satellite communication, I'm going to talk about the link budget calculation. Of course, what do you mean by link budget calculation? When the signal travels from the ground station to the satellite, okay, the signal will travels between 2 points, okay, and again these 2 points within the channel of wireless channel. So we are going to measure the signal at the input and at the output. What do you mean by input and output? I mean at the base station or ground station and at the satellite point. Again, we may have a signal which travels from the satellite to the ground station. Again, we are going to measure the signal at the 2 points. Of course, this method or this technique is called link budget calculation. I mean, we will be able to determine the carrier to noise ratio and signal to noise ratio of the system. So basically, wireless communication will contain these 3 systems: cellular communication system, CDMA, and satellite communication. This is about the course layout. Of course, as I have told you, the fiber optic topic will be given by Dr. Saleh. Now, first of all, before talking about the wireless communication system, now every communication system consists of 3 elements. Okay, now we have a transmitter, then the signal will travels through a channel, and here we have what? Here we have a receiver. Okay, so any communication system consists of what? Consists of 3 elements: transmitter, receiver, and channel. As I think you are familiar with the say AM modulation, FM modulation, PM modulation, and some kinds of the digital modulation techniques like ASK, FSK, PSK, QPSK, and QAM. Now, can anyone tell me why we are modulate the signal? I mean, what's the benefit of modulation?
To reduce noise.
To reduce noise. Okay, so it's an opinion. Another one.
We can't travel original signal too far distance.
Repeat, please.
We can't travel original signal to far distance.
Yes. What do you mean by original signal?
The base signal which contain information.
Good. Is good. What's your name?
Ahmad Imadadin.
Okay, now I'm going to tell you some principles, okay? Some principles to understand what's going on. Look, please. First of all, in communication I'm talking about, of course, basically in communication system, we have 2 kinds of signals, okay? In communication point of view, look, please. Signals, okay? Signals can be divided broadly into 2 kinds, okay? First one is called base band signal. Okay. The second kind is called band pass signal. Now, what's the difference between these 2 signals? And give me an examples about each kind. Okay. Baseband signal and band pass signal. Who can give me an example about baseband signal? Safa Chare. Are, an example about baseband signal.
Dr. Mana, baseband, we don't need modulation.
ايه يعني وكي تشتشت اريانا نا ودنجي ارياني ازبيجن
بله دكتور.
ايه اريان وكي تشتشت
The example I don't know, but I know.
مالته وكي دنج وكي او يدهمتشت لا okay. Real signals, information signals are what? Are baseband signals. Okay. يعني مثلا speech, okay, speech signal, temperature, voltage, اما ويش تشتغل خير او يدينا baseband signal. ايه band pass signal example. طبعا baseband signal any information signal. Any information signal. ايه band pass signal example search تشتغل.
تلاقي خاطر تلفوني هون
ندت
الانترنت
هذه نظام شكيه. ايه band pass signal تشتغل example for band pass signal.
تلاقي خاطر تلفوني هون سيجنال تلفوني
ايه
بالانترنت هون يعني بهم انفورميشن.
اوكي يعني in other words يعني in other words
دكتور وكي راديو.
ايه وكي راديو بري خوبدن باند باس سيجنال بس بري خوبدن باند باس سيجنال زي يعني معناها بعد ما تشتا يعني modulated signal. any modulated signal is called what? is called band pass signal. طبعا بوشي بري خوبدن جماعات نوكا مثلا AM signal for simplicity. For example, if I'm going to talk about the AM signal, okay, for AM signal, the signal will be at FC and minus FC. Of course, I'm talking about double-sided spectrum, okay, and this will be the information signal, okay. يعني تشتشت يعني the information signal is what is shifted by carrier FC, so it becomes what? It becomes band pass signal. So how we are going to recover this signal directly without down converter? Of course, we need a band pass filter in such a case. Okay, so modulated signal is called again band pass signal. Of course, a very simple example about what? About AM signal. Okay, now you can distinguish between what? Between two kinds of signals: baseband signals, which are what? Which is the information signal, and band pass signal, which is the modulated signal. So whenever you hear about band pass signal, directly we have to think about what? About modulated signal. Is it okay up to now? As I think it's clear. Now, again, going back to our question, we said that why we are going to modulate the signal, or why we are going to modulate the baseband signal. One of you talks about interference to reduce interference, okay, and more
reduce attenuation.
طبعا no, we can't reduce the attenuation, because the attenuation is the channel characteristics. It's good. Okay, let us discuss the points and make a negotiation. Good. Another thing. Okay, now really we have a main result, or main reason behind what? Behind using the modulation, or behind utilizing the modulation techniques. Why? Look, please, as I think you remember this formula, lambda equals to what? C over F. Do you remember this formula or not? أري يا جماعة. Lambda is what? Lambda چیه lambda? Wavelength نه؟ Wavelength. C چی تشته؟ Speed of light 310 to power 8 چی تشت؟ meter per second. And F frequency. Okay, now lambda is a very important parameter. Is a very important parameter when we are going to design a receiver. Okay, when we are going to design a receiver, most of the times we are going to design a receiver with antennas. Okay, to receive what? Receive the signals. Now, length of antenna proportional to what? Is it proportional to whom? To the lambda, I mean the wavelength. So we have different kinds of antennas. For example, lambda by 2, lambda by 4, and so on. These are what? These are the wavelengths or the lengths of the what? Of the antennas. Of course, lambda, unit of the lambda will be in what? In meter. Okay, now let us talk about this kind of signal. Now, for example, say we are going to use an lambda by 2 antenna. Okay, lambda by 2 antenna. Okay, lambda by 2 antenna, and we are going to receive a signal which has a frequency of 1 kilohertz. Okay, F naught is equal to 1 kilohertz. So let us determine the wavelength for this signal. So it will be lambda equals to 3 multiplied by 10 to power 8, 10 to power 8, divided by 1 multiplied by 10 to power 3. So what will be lambda? Lambda will be 3 multiplied by 10 to power 5. Wow. So it is what? Meter. In other words, it will be 300 kilometer. So if you are going to use a lambda by 2 antenna to receive such a signal, our antenna will be in terms of what? In terms of kilometers. Okay. So this is the main reason behind what? Behind using the modulation techniques. What we are going to do? We have to use small antennas. So how we are going to use small antennas? Of course, we don't have another choice. Going back to the same equation, I mean the equation of C over F, and F must be increased, okay? Must be increased for what? For reducing the length of the antenna. So when we are going to use, for example, frequencies in terms of megahertz, okay? 100 megahertz or in gigahertz, at that time, the antenna dimension becomes what? Becomes a few centimeters. Of course, if you are going to use special kinds of antennas, for example, like microstrip antenna, at that time, again, we have to increase the frequency more and more, and the dimension of the antenna will be reduced in a few centimeters or 1 or 2 centimeters. So this is the main reason behind using what? Behind using the modulation techniques. Okay. Now, is it clear this point or not?
Yes, Doctor.
Okay. Okay. Now let's go back to the our lectures. So again, we said that any system consists of transmitter, channel, and receiver. Of course, in this course we have a course entitled Advanced Communication Systems. Of course, why we said it is systems? Because every system has its own channel. Okay, own channel characteristics. Well, so we are going to study different systems in this course. Okay, now let us start with the PowerPoint slides. Again, I'm going to basically depend upon this book, okay, Wireless Communication Principles and Practice, second edition by Theodore S. Rappaport. Of course, again, the solution manual of this book is supplied. So you can depend upon this book directly for what? For the cellular communication system and standard communication systems like the GSM. I'm going to talk about 2 chapters from this book. Chapter 1, inshallah, we're going to talk about it, and chapter 3 in detail again. To chapter 3, we have chapter 11, chapter 11, which is wireless systems and standards. Of course, I'm not going to talk about the whole of the chapter 11. Just I'm going to talk about the topic of the GSM. Okay, GSM system. So we are going to talk about again the GSM. I mean its architecture, benefits, features, and so on. So we have 3 chapters: chapter 1, chapter 3, and chapter 11. We said that just one article from chapter 11, sorry, which is the GSM system. Now let's start with the PowerPoint slides and the introduction to the communication system. Of course, lecture 1 will be contains some kind of boring. Why? It contains a lot of explanations, but this chapter is very important, and this lecture is very important to understand the whole course. Well, at the beginning, the first system or to provide wireless communication is done by Mr. Marconi. First demonstrated radio's ability to provide continuous contact with the ships sailing in the English Channel. That was in 1897. Okay, so this is the origins of the wireless communication. Then day by day we have developed the systems, and by now we have a lot of wireless communication services. Now, particularly during the past 10 years, the mobile radio communications industry has grown by orders of magnitude, fueled by, of course, sometimes we may say, what are the reasons behind the developing of the wireless communication systems? Really, we have the following 4 results: digital and RF circuit fabrication improvements, a new large-scale circuit integration, other miniaturization technologies which make portable radio equipment smaller, cheaper, and more reliable. 4, digital switching techniques have facilitated the large-scale deployment of affordable, easy-to-use radio communication networks. So these are behind the revolution of the wireless communication system. Of course, here we have a brief introduction about the revolution of the mobile radio communication. Of course, why we are going to study such a thing? Okay, it's important for what, or useful for what? Useful in order to appreciate the enormous impact that cellular radio and personal communication services will have on all of us over the next several decades. Okay, so this is the reason behind studying this technique. Now, wireless communication is enjoying its fastest growth period in history due to enabling technologies which permit widespread deployment. Historically, growth in mobile communication field has come slowly and has been coupled closely to the technological improvement. Now, can anyone tell me what's the difference between wireless communication and fixed communication? In a few words. Any differences? Can anyone tell me a difference? Not differences, a difference between wireless communication and fixed communication? Huh?
Doctor, error detection is easier in fixed, in wired communications, while in wireless it's harder to detect errors.
Yeah, it's okay. Another thing.
دكتور وايرلس بوايرة
يعني çitişte aferin ebe bewaira ebe bwaira درسته يعني faydalı çitişte.
دكتور وايرلس تشبه بس واير كوميونيكيشن تنشبه هم عرضه يعني less distance.
إذا ما نروحش تجيلك ريسيفر وترانسميتر
بس مباركة يا زحمات دباركة محمد زهير بنا
ناخذ دكتور ازمه ايسان
كيف
ايسان
هيثم ايه
دكتور وايرلس مروفشت بهامي عرضة چونكو يعني فري ديستانسا
ايسان عبدال ايه ايسان سرشا ايسان ايه درسته ايه ايسان ايه عفرم ايه
فري ديستانسا بس وايرد كوميونيكيشن تناشي بهامي عرضة يعني ليميتد ديستانسا
دست خوش راستی بجمتم او فرق رئيسي جوازين بيني fixed communication and wireless communication is what we can say about the wireless communication is what it's anytime anywhere okay anytime anywhere عفر مايسن while the fixed communication yes is anytime but not anywhere okay so this is the main difference between what between the wireless communication and fixed terminal communications okay it's good now of course, the first system is developed, or the ideas really, developed by the Bell Laboratories system, okay, which talks about the cellular concept in 1960s and 1970s, okay, with the development of highly reliable miniature solid-state radio frequency hardware in the 1970s, okay. So the wireless communication era was born. The recent exponential growth, okay, recent exponential growth in the cellular radio and personal communication system throughout the world is directly attributable to a new technologies of the 1970s, which are mature today. Okay, look at this figure, please. Okay, now this figure contains or talks about different services. Look, please. X-axis here is what? Is a number of years after the first commercial deployment. Okay, so 10, 20, 30, 40, 50, and so on. Well, so we have different services. For example, we have video cassette, recorder, television, okay, cable television, automobile, telephone, I mean landline telephones, okay, and here we have what? A mobile telephone. Look, when we are going to compare the differences between the mobile growth and the other services, look, sudden change, okay, in the curve has been done, okay. So what we can expect, so it means that this service is required by what? By huge number of users or subscribers. Well, so based on this study, it means that the field of mobile communication or even the wireless communication is an important field, okay, and it's worth to study such a field, okay. So from this figure we can conclude this fact, that the mobile telephone users is increased exponentially. So we are going to study such a topic. It's an important topic to be studied. Well, now we have many standards around the world. Well, so we are going to talk about these different standards. Table 1.1 through table 1.3 lists the most common paging, cordless, cellular, and personal communication standards used in the North America, Europe, and Japan. Of course, why we are talking about these three different regions or countries, because look at the table. Now, as you can see from this table, of course, this is the advanced mobile phone system, which is used in the USA. Type of the modulation, type of the service, sorry, cellular. Year of introduction, look, year of introduction is 1983. Okay, in 1983, in the developed countries, okay, like the Middle East countries, okay, we haven't heard about the wireless communication. And from 1983, they are using the cellular systems. type of the multiple access is what? Frequency division, multiple access. Frequency band is 824 up to what? Up to 894. So what will be the total bandwidth? Ari Jamaat, what's the total bandwidth of the advanced mobile phone surface system? 70 mega, no more. Okay, and the channel width is 30 kilohertz. Good. Now, can anyone tell me what do you mean by multiple access systems?
We can divide the channel between multiple users, like frequency channel.
No, dividing the frequency between, I mean the bandwidth, the original bandwidth between many number of users, it's called frequency division, not multiple access. What do you mean by multiple access? What's meant by multiple access?
Many users can use the same bandwidth in the same time.
Can use the same bandwidth in the same time?
There will be interference, but I mean, they all can use the same bandwidth, the same channel.
Repeat it again. Repeat it again.
That we have.
No, wait. Okay. Reset. Start from 0. Yes. Say.
Okay.
Yeah.
When you have a channel that many users can access, it's called CDA, and we need solutions for interference, and we have to schedule which one will transmit in a specific time to avoid errors.
It's good. It's good. You have explained or defined what do you mean by the multiple access channels. Okay, now it's good. But for deep understanding what we talk about the multiple access, now I need one of you to give me a real example, real life example about something which is a multiple access thing. Do you have an example about it or not? Anyone, طبعا, of course, may give me this example. Real life example I need. Huh? Can anyone give me a real life example about multiple access? We have a lot of examples. Yeah. Who can help us?
Our router and internet devices in the home.
Router and internet devices in the home? How it is multiple access? In router and internet, it is we are going, for example, to make. Sorry, I'm sorry. I'll give IP for everyone. Okay, so we don't have a problem. Real life example about multiple access.
دكتور تلفوني قديم مالتيبلكس نبو
ناخر يعني
For television cable.
Television cable? Television?
Yes. Yeah, television.
No.
Because it's a single medium, but it's used by multiple access.
No. I'm talking about real life examples. طبعا جماعة بس دقة طبعا I'm going to continue about this example I'm talking about it. About your attendance جماعة, about the attendance يعني أما دبونا طلبة. جماعة, I don't need in the chat to write down your names in the chat, okay? And I'm going to read your names based on the lists. Really, we have a prepaid Zoom account, okay? So this prepaid account has many features. One of its features, reports, okay? Reports. Zoom will provide us with reports. Of course, reports about what? About the participants. I mean, you and me. Well, so using these reports, okay, I'm going to what? I'm going to evaluate the attendance of the students. I mean, for every student, really, I have to tell you about this thing. You have to use your name, full name, okay? Why? Because in the Zoom report, it will uses your name and the email, okay? And the email used in the signing in the Zoom. Well, and the report again will provide us with two things. The starting time, I mean, at which time you have engaged in the session, and at which time you have departed from the session. And in the third column, we have the net time. I mean, the duration of each student. For example, we may have a lecture about 1 hour. So we may have some students stay at the lecture at, for example, 10 minutes, no more. And we may have students who may stay at the lecture for example 1 hour or one and a half of the hour. Okay, so the attendance of the students will be what? Will based on the what? On the Zoom reports. Okay, so it will be very accurate and provide us with Excel sheets easily. Well, so from now on, always I'm asking you to write down your full name. Okay, to write down your full name, because the full name and your email will be used for what? To record the attendance of each student. Well, now going back to the multiple access technique. What do you mean by the multiple access technique? Real life examples, really, real-time examples. I'm talking about these real times for what? To understand the basics of the multiple access correctly. For example, roads. Okay, roads. The roads are used by what? By many users every day. Okay. Again, barber chair. Okay. Again, is used by what? By many persons. Okay. So all of these are what? Are examples for what? For the multiple access. Public transportation. Okay. Public transportation. Again, an example for what? For multiple access techniques. Well, so when we talk about FDMA, it means what? It means this channel is used by more than one user. Well, so FDMA means frequency division multiple access. Of course, the original bandwidth is divided into what? Into a set of channels. And every individual channel may be what? May be accessed by more than one user. Well, then after the advanced mobile system is updated, becomes an advanced mobile phone system, cellular system in 1992. Again, it uses the FDMA and with the same bandwidth, total bandwidth. Modulation type was, of course, FM, but the channel width is reduced to 10 kilo. Of course, what does it mean? It means that more channels will be provided. I mean, more number of users will be provided, and then we can conclude that the capacity of the system is increased. So this updating for the advanced mobile phone system leads to what? Leads to increasing the number of subscribers of the users. Then we have another system which is USDC, cellular communication, 1991. And okay, I'm sorry, we have failure in the electricity. Okay, now going back to the sorry, unmute. Well, then we have another system which is the USDC cellular communication system, which is in 1991. The kind of the multiple access becomes TDMA. Of course, in this system, the digital modulation techniques is introduced, and it means that the ciphering and securing of the communication begins. Again, the same bandwidth, while the modulation type is pi/4 differential quadrature phase shift keying modulation, and the bandwidth is 30 kilohertz. Then another system we have, CDPD, which is cellular communication system in 1993, and the frequency hopping packet. type of modulation is Gaussian minimum shift keying modulation. We have and then another standard, which is the paging. Of course, we are going to define what do you mean by paging and explain what do you mean by paging in the next lecture. I mean tomorrow, inshallah. Cordless telephone and other standards. Now, here we have some standards in Europe. You can see we have ETAX, NMT 450, NMT 900. Sorry. Again, these are year of introduction. 985, FDMA, 900 megahertz. Okay, frequency band. FM 25 kilohertz. Another system which has another bandwidth. This is again has its own bandwidth. Then we have the GSM system, of course, which is developed by Sony Ericsson company, 1990 TDMA, and this will be the bandwidth for the GSM, and the kind of modulation is GMSK, Gaussian minimum shift keying. Bandwidth of each channel is 200 kilohertz. Of course, why I am going to talk about these tables? Look, please. As you can see, every standard or every system has different bandwidth. Look, please. GSM starts from 890 to 960. Again, NMT the same bandwidth, but look at the others. They are different bandwidths. Again, if you are going back to the bandwidth used by the USA companies, they are again different. Okay. So up to now, we don't have a unique bandwidth. Of course, these are the problems of the first generation cellular communication system. Then after we looked for finding out a unified bandwidth. I mean to find out a unique device which can be used all over the world. So at the beginning, we have different standards and different systems. Then we have used standard or unified bandwidth. Okay, now here we have an important thing, some mobile radio terms we have to talk about. Most people are familiar with the number of mobile radio communication systems used in everyday life, like garage door opener, remote controllers for home entertainment equipment, cordless telephone, handheld walkie-talkies.
بس سلايد شنو ابو؟
دقيقة. I'm sorry. دقيقة والله. رياسته مشكلة يا ابو. العفو. لوكا درست أنا؟ Okay. Well, now to understand the mobile communication system, we have some mobile terms. The mobile term has strictly been used to classify any radio terminal that could be moved during the operation. But by now, mobile is used to describe a radio terminal that is attached to a high-speed mobile platform, for example, a cellular telephone in a fast-moving vehicle. Okay, now this is the term mobile. Well, so mobile term now is updated, whereas the term portable describes a radio terminal that can be handheld and used by someone at walking speed. So at walking speed, they are considered as as portable devices. While when we talk about a device, a receiving device or a communication device, which is attached to a fast moving vehicle, at that time it will be considered as a mobile unit. Again, we have another term, which is the subscriber. Okay, is often used to describe mobile or portable user because in most mobile communication systems, each user have to pay a subscription fee to use the system. So users of any system are called what? Are called subscribers. Well, and each communication device is called subscriber unit. In general, the collective group of users in a wireless system are called users or mobiles, even though many of the users may actually use portable terminals. Well, table 1.4 lists definition and terms used to describe elements of wireless communication system. Of course, to understand this thing, let us go at the beginning to the whiteboard to explain something, and I'm going back to explain what do you mean by each term. Now, regarding to the terms, to understand what's going about the terms, look please, any communication system, any cellular communication system really, which consists of the following. We have a set of base stations, okay, a set of base stations and we have a central unit, which is the MSC. All base stations will be connected to the MSC through either say fiber optic cables or microwave links. So the base stations are controlled, are managed by the MSC, which is the mobile switching center. Okay, this is called mobile switching. Sorry. Mobile switching center, or sometimes it's called mobile switching office. Okay, and these are base stations. Of course, the base stations to be connected to the mobile units. Okay, again we have uplink and downlink. This is the basic system of the cellular communication. So we have the following elements: base station, mobile station, and MSC. Of course, we have different kinds of channels. We have traffic channels and control channels. We have forward channel and reverse channel. All of these are different kinds of channels used in the cellular communication system. For today, it's enough. Tomorrow, inshallah, we are going to continue with our lectures according to the department schedule. Thank you and see you tomorrow, inshallah. Do you have any question or not?
دكتور
بلي عزيزي كلامك.
دكتور بس بريدو دقة نظام وايت بورد تشتغل في سي أنا
نا دف من كهرب قطع ببورة بريد صدقة عليه. Okay, جماعة, see you tomorrow inshallah. Thank you and goodbye.